All right, so today we're going to be looking at 5-3 medians and centroid, and then altitude and orthocenter. So we're going to be introduced to 4 new vocabulary words today. So before we get started on that, I just want to do a quick little recap of the first 2 lessons of this chapter. Since we're about to reach the midpoint of this chapter, I just kind of want to remind you what we've gone over before, just to have a little review. So remember, 5-1, we talked about perpendicular bisectors and angle bisectors, okay? So forming a 90-degree angle and bisecting that segment. So perpendicular bisectors, angle bisectors. So then we went into 5-2, we were talking about a circumcenter where perpendicular bisectors meet, okay? So where all of these perpendicular bisectors meet, that's the circumcenter. And then we talked about the incenter where the angle bisectors meet. Okay, so kind of see the relation how first we learned what perpendicular bisectors were, and we learned what angle bisectors were, and then we learned that, okay, where all the perpendicular bisectors meet, that's called the circumcenter, and then where all the angle bisectors meet, that is called an incenter. So 2 big vocabulary words, and now we're going to introduce 4 more vocabulary words. So this chapter really deals with a lot of vocabulary. So it can be kind of a lot, but with some practice and going over some, Quizlet study sets and things like that, you should eventually get a little more familiar with these words. So our first word that we're going to go over is median. So these are 5-3 notes. So I would go ahead and label those on your paper as well. So just write 5-3 at the top just to help you keep track of what those are, and just kind of keep them together and in order. So a median, you have probably heard the word median before in reference to data. When we find like median, mode, range, remember all of that you did in algebra and back in 6th grade. So it's a little bit different when we're referring to median of a triangle, so a slightly different definition. So you have a picture here and it's showing you the median, and it still kind of has to do with the middle. We think of the median as the middle number in a data set. When you're driving down the road, the median is in the center of the road. So what a median in a triangle is, it does create a midpoint, but it's this segment that's joining a vertex to the midpoint of the opposite side. So a median, it is this like midpoint here between these 2 sides, but it's this whole segment that's connected to a vertex. Okay, so that right there is a median. So we're going to define it as a segment joining a vertex to the midpoint of the opposite side. So in our minds, we're still thinking of median as the middle. It creates this middle right here, but we're referring to this kind of segment right here. And notice it is cutting this opposite side in half. So it's cutting this opposite side in half. It's not necessarily cutting like the triangle in half. It's cutting just this side in half. So that's a median. And now we're going to learn another type of center in a triangle, which is a centroid. So all of these interesting vocabulary words, they just all sound funny to me, but this one is centroid. And this is going to be, now relating back to medians, this is going to be where the 3 medians of a triangle intersect. So our basically third type here is centroid. So we did circumcenter, incenter, now centroid, and this is where the 3 medians of a triangle intersect. So the difference kind of with a median compared to, say, a perpendicular bisector, they're not necessarily forming 90-degree angles. When these medians cut this segment in half, it's not necessarily at a 90-degree angle, and you can see that. So it's at different angles here. But these medians all intersect, and they would intersect at this point called the centroid. So we're going to do something similar that we did with circumcenter and incenter. We're going to label them, or label our medians, and then kind of look at the special properties. So let's list the medians. So your medians are going to be these lines that are bisecting or at the midpoint of each segment. Okay, so I am going to highlight these again so you can see them. So all my medians, I'm going to highlight in green so you know what we're talking about. So the medians, we have this whole thing here, this whole line here, and then this whole line. So you can see now the difference with the median is we're talking about the entire line rather than just the half. We're talking about it extends from this vertex all the way to its opposite side, from the vertex to its opposite side, and then from the vertex to its opposite side. That is the median. So then let's just label what those medians are called. So we're talking about the whole segment again. So let's call the first one AE. Then we've got BF and CD. Okay, and then all of those meet at point P. So we're going to call that P. And then now let's look at the special properties that exist for each median. So there just happen to be these special relationships with a median. One of those being that AP, okay, so AP is this part here. It is actually double PE. Okay, so this part here, okay, so this is one whole median. This longer part here is double the size of the shorter part. So this is saying, so AP is 2 times the length of PE. So the shorter part is half the length of this longer part. Okay, so that's AE. Then we have PE, so this shorter part, we're going to say this kind of in the opposite way of how I just said that. So PE, this is half the length of AP. So 1/2 AP. So they kind of go together. They're really kind of saying the same thing, just opposite. So this part is double this part, which then means that this part is half of this length here. Okay, so that's one special property. And the second special property is that this part AP, okay, is 2/3 of the whole entire thing AE. Okay, so I'm going to write it like this and then show you. So AP is 2/3 of AE. So AP is 2/3 of AE, the whole thing. So if you kind of imagine basically cutting this in 3, so cutting this whole median in 3, like if I had another dash right there, so I cut that segment into thirds, this is 2/3 of it, okay, this is 2/3, and then this is that other third. So the other third is right here. So then I'm going to say that in the opposite way. So then that means that PE is 1/3 of AE. Okay, so imagine what I'm going to kind of do is just take a little sketch here of AE just to show you this a little bit better. See, if AE, you have P, say right here, and then let's just say we have this other point right there. So now it's in thirds. Okay, so this part here is 2/3, and then this part here is 1/3. That's what this is saying. So this is, some fractional number sense. So you have 2/3 and then 1/3. Okay, so that's a special relationship here. So that's all of the stuff about centroid. Okay, so let's look at some examples of these and find some missing measures using what we know about the centroid. So with these examples, we're going to be finding missing measures, and I will say they do get harder as we go through. So the first one will start off pretty easy, and then by 4, it is a little bit more math and calculations and applying these special properties here. So it does involve a little bit of work with fractions, just fair warning. So the first one, though, isn't so bad. So for the first one, they're giving us some information. They say P is the centroid. So our job is to know that, okay, if P is a centroid, then all of these are medians. All of them reach the midpoint of the side length, and then they all have these special properties where if you think of this in your head, like what we're saying here, the longer part is double the shorter part of the median. Okay, so the longer part of the median is double the shorter part of the median, and then also the longer part of the median is 2/3 of the entire segment. Okay, so it's 2/3 of the entire median. Okay, so a little confusing, I know. So we'll look at those in some examples. But let's first do number 1, which is going to be a little bit easier. So just kind of knowing that each one of these is a median, and so it cuts these sides in half. So I personally like to just label my sides that are congruent. So like I know this median is it's the midpoint. So it's cutting this KJ in half. So I'm just going to label that those two are congruent. These two are congruent. So it's cutting it in half. And then these two are congruent. And I just like to label those. It helps me out. You guys do your EOC online and you do a lot of practice online because of that. So I still, even if you're doing online practice, sketch out a little picture and kind of label. I think that's just the best way to go with math. Just sketching it out and labeling it. So now they tell me JK is 22. So JK is 22. So the whole thing is 22. All right. So right away, we know that each half is 11 because that's what they're going to ask us. So if this whole thing is 22 and these sides are equal, cut it in half, so 11 and 11. All right, so let's look at the next one. So KN, now they're saying, so this part here, KN is 13, which then also means that NL is 13. And then they say OL, so right here, 18, which means JO is 18. Okay, so now, I pretty much have everything figured out. I'm just going to go fill in what they asked me for. So they asked me for KM. What's KM? I already labeled, that's 11. Okay, so since we cut that 22 in half, KM is 11. Then they asked for NL. NL is right here, is 13. Then they asked for KL, so this whole thing, okay? So we're just going to do 13 times 2, so double 13. So that's going to give us 26, and I can just put that there so you kind of know where that came from. So 26. And then JO, so asking for that segment there, which we labeled as 18. And then they ask for JL, so the whole entire segment here. So we're going to double 18, and that gives us 36. Okay, so we did number 1. That one, I will say, is like a level 1 problem, so it's easier than the others, because once we start looking at the inside, so once we actually start looking at these medians, we kind of have to deal with these little fractional relationships. It's not so simple as just cutting it in half. We get into like the 2/3 and the 1/3. So let's take a look at number 2 and go ahead and label what they gave us. So Z is the centroid. So we've got a bunch of medians. They're cutting those side lengths in half. And then let's look at the internal parts of the median. So it says that TZ is 60. So I'm going to label this part right here. So this the longer part of the median. That's what I'm going to refer to that as. So the longer part and the shorter part. So the longer part is 60. And then what else? XZ. So the shorter part here of this median. So the shorter part of this median, XZ, is 28. And then WZ, so the shorter part of this median is 25. Okay, so to kind of recap, they gave me the longer part of this one, the shorter part, and then the shorter part. So I am going to be applying these special properties, okay? Specifically, the first special property is what I'm going to be looking at. The fact that the longer part of the median is double the shorter part, okay? If you want to write that out in words, that might help you to kind of decipher. Maybe I'll put that here. I mean, it's not a very mathematical statement at all, but it might help you in your head. So I'm going to put the longer part of the median is double the shorter part. That's not a very mathematical way, really use, the segment. So the longer segment of the median is double the shorter segment, kind of the same thing. But this might be the way you can think of this in your head, that the longer part is double the shorter part, because that's going to help you figure out these missing angle measures. Let me also zoom in on that so you can see better. And if you need to pause and get this copied, feel free to pause so you can get all those copied. Hopefully you can read that. How about I zoom in even more? And really that's just a notation to just kind of help you decipher what this is saying. So the longer part of the median is double the shorter part. So we're going to apply that in the next one. So if you need to pause and finish that, feel free to pause, but I'm going to go ahead and go to these examples here. Okay, so A. So now we have all these labeled. They want Z, V. So they want to know right here. Okay, so now they're asking for the longer part of this whole median, XV. So we know the shorter part is 28. We want the longer part. What did we just say? The longer part is double the shorter part. So we need to double 28. So we're just going to do 2 times 28 over here, which is going to give us 56. Okay, so this is 56. So notice again, the longer part is double the shorter part. Okay. So let's use that again. So now they ask for ZY, so they're asking for the shorter part. We have the longer part is 60. So if this is double this segment, so if 60 is double this number, what would it be? So cut 60 in half. That would be 30. That's a 0, not a 6. 30. Okay. So again, the longer part is double the shorter part. So let's apply that again. So if you kind of get that, then you can kind of figure out what the other ones are. If you want to pause, since I kind of explained, you know, the first couple, you could probably figure out the next three. So if you want to pause and try this on your own, just so you get a little bit more comfortable with it, I would encourage that. So give a pause, little mental breather as well, and see if you can figure those out. Okay, so if you paused and tried them on your own, what you would have ended up with is ZU would have been 50. TY, so right here was 50. So this is double that. TY, now the whole entire thing. Okay, so maybe you could have gotten that one. It was different than the other ones. But so if this is 60, well, oh, we had already figured out. I just didn't label it. Sorry. So 30, so 60 and 30 would give you 90 for that whole thing. And then XV, so this whole thing, if we just add 28 and 56, we get 84. All right, so now I would like you to try number 3 all on your own. So it does relate pretty closely to number 2, just really applying the fact that that longer part of the median is double the shorter part. So give 3 a try, pause the video, see how you do with it, and then we'll go over it. All right, so hopefully you gave number 3 a try. I'm going to show you the answers here. And then let's see. So this was number 3. All of them were pretty much applying what we just talked about. So you have GD, which is 4 because it is half of 8. So they gave you AG was 8, so half of that is 4. And if you kind of go through and just label, you know, what they gave you. So like they gave us GF right here. So they gave us that was 7. So then you can automatically think like, okay, this is 7. Double that would be this part over here, which is 14. And then they said BG is 5. So double that would be 10. And then they were all pretty much, you know, like that. And then the only one I think it was slightly different was BE. So they asked for the whole thing. So we just add 5 and 10 to get 15. And then that's it. So let's go ahead and take a look at number 4. And 4, I am going to do with you. So 4 is going to take it up a little bit, kick it up a notch. We're going to have to use the second property on number 4. So I want to go over that one with you. All right, so for number 4, they tell us X is the centroid, and then what they end up giving us is pretty much the entire length of the median. So rather than giving us just a part, either the longer part or the shorter part, they give us the entire median. So they tell us that TU, so the whole entire TU is 27. So I'm going to kind of label that like that. So that whole thing is 27. And then SW, so that whole SW is 18. And then RV is 21. And now, so that's kind of confusing the way I have it labeled because that 21 is referring to that entire thing. So that whole thing is 21. Okay, so what do you notice about 27, 18, and 21? They all have a common factor. That common factor is 3. So why am I saying that? Remember that if you look at the second property up here, it's basically saying that the longer part is 2/3 of the whole median, and then the shorter part is 1/3 of the entire median. So we're talking about things in thirds. Okay, so imagine cutting each of those medians into thirds. So for example, if I pull out, you know, say this median right here, WS. Okay, I'm just pulling that out just so you can visually think about this a little bit. WS or SW, either way they told me is 18. Okay, so I know it intersects about a third of the way through, like right there. And remember that this is 2/3 of it, this is 1/3. So if I think of this in 3 parts, so let's say I break it up, so that should be 3 equal parts, say. Well, what would 18 divided by 3 be? Okay, so if you take 18, divide it by 3, what would you get? You would get 6, okay? Meaning that you have 3 equal parts, 6 and 6. So if you divide it by 3, and there are other ways to think about this, there you can set up a little equation, you know, that's one way to do it, but I like to just think of the numerical sense of it. So if I think of just dividing each of those medians by 3, then I find that easier. So now I know that the shorter part is just 6. Okay, so if I look at this, I was looking at SW, the shorter part is 6, because 6 times 3 is 18, and it's 1/3 of the entire thing. So 1/3 of this whole thing would give you 6. You can also set that up like this. 1/3 times 18, which is really just 18 divided by 3, which is 6. Okay, so just 2 different ways to get it. So really what I just think of, when you have the whole entire median, you can divide it by 3, and that's going to give you the shorter part. Okay, so let's apply that again with some of the other medians. I just happened to pick SW first. Let's look at TX. So with TX, that's going to be the longer part of TU, which they told us was 27. So if I think of dividing 27 by 3 again, then I can figure out what the shorter part is and then the longer parts. So you can also take 2/3 of 27. I find that to be just a little bit more work. So I'm going to look at the fact that TU, this whole thing is 27. So I'm going to divide 27 by 3. And that gives me 9. Okay, so that means for TU, the smaller part is 9. The smaller part is 9. So that means the larger part is double that, 9 times 2, which would give me 18. Okay, so let's recap that. Basically, I take the median value, so the whole entire value of, or the length, I should say, the length of the median, and then I just divide it by 3. That gives me the shorter part, and then I double it to get the longer part. Okay, so let's try it again. So they asked for TX, then they asked for XU, which I already got. So half of that would be 9. So they asked for the shorter part and then the longer part for this median here. Now let's look at the next median. So if we're looking at SX, so this longer part here, SX, and for SW, so that's part of that whole median SW, which is 18. So I just had to kind of figure that one out over here. So for SW, this whole thing, it's 18. So if I divide it by 3, I get 6. Okay, and then if I double that, then I get that this longer part is 12. So that means that SX would be 12. Now let's do XW, so the shorter part of it. So if this longer part is 12, half of that is 6. So a third of that 18 is 6. So 18 divided by 3. And then RX, so this longer part of this whole one, RV. So we haven't figured this one out yet, but it's 21. This whole thing is 21. So if we figure out the shorter part, we can divide by 3 and then double it to get the longer part. So I'm going to kind of do my steps over here. So this whole thing is 21. So I'm going to divide 21 by 3 to get 7. So that means this shorter part is 7. So what would the longer part Rx be? Remember, we double it, so it would be 14. All right, so now we're going to take a look at the next page, the back. So we're going to talk about altitudes and orthocenter. So the last type of center that we're going to talk about with triangles and then define what an altitude is, which would be something that looks similar, but is a little bit different. So to kind of compare a little bit, kind of see the difference here. Let's see. Okay, so notice the difference in our triangles. It looks like in this one, a median cuts that segment in half, creates a midpoint. Looks like our altitude is perpendicular to the side. So we have, for this one, we have a segment that's joining a vertex. For an altitude, we're going to have a segment joining a vertex again. However, instead of it being the midpoint, it's going to be perpendicular. So I'm going to write here an altitude now. Zoom in. Is a segment joining a vertex to the opposite side, so same as a median, so that it is perpendicular to that side. So now it's not the midpoint of that side, so it's not cutting the side in half, but it is perpendicular, so creating that 90-degree angle. So that it is perpendicular to that side. Okay, and so this right here is an altitude. Okay, so it goes from the vertex to the opposite side, and it's perpendicular to that side, so it creates a 90-degree angle. So with an altitude, they can be inside a triangle, outside or a triangle, or even a side of a triangle. So that's a little bit different. So meaning it can be actually a part of the triangle, not necessarily a line that's just drawn inside the triangle. So we're gonna show you that here on these. We can draw an altitude just like this one. So from the top to the side opposite of it, so it creates that angle. It can also be outside of the triangle. So if I have the vertex here and I go down, okay, and then extend to the triangle, so it's outside, but it has that 90-degree angle. And I'm going to label them as A for altitude. And then on one like this one, you already have, this is a right triangle. So you already have this 90-degree angle. So this whole little side right here, that would be your altitude. Okay, so that's a little bit different. It's not a line that's drawn inside there. It's just part of the triangle. It's really a leg of the right triangle, but it's also an altitude. Okay, so now we're going to use our knowledge of altitude. So now we kind of know what an altitude is. It goes from the vertex and it's perpendicular to that side. And we're going to look at the orthocenter, so a new center for triangles that we're talking about. So now, remember in the last one, we had the 3 medians intersecting. Now we have the 3 altitudes intersecting. So the 3 altitudes of a triangle intersect at a point called the orthocenter. We're going to list the altitudes and then name the orthocenter. So there's actually a little bit less to this one because it doesn't necessarily cut the side lengths in half, and it doesn't necessarily have a nice little relationship, so there's actually not too much to it. So let's just list the altitude. So all of the ones that extend from that vertex all the way to its opposite side. So we can write CD, any order, it doesn't matter, CD, then we've got BF, and then we've got EA. And let me just highlight those two so you can see. It's the whole thing we're talking about, not just the little part. We're talking about the whole entire segment. So it goes from the vertex and it creates a 90-degree angle. Whereas a median doesn't always create a 90-degree angle. A median can create a 90-degree angle, but only if it's an equilateral triangle. So these are all your altitudes, and then that center part, I should name it. I need to name it. That center part is called P, and it's the ortho center where they all run into each other. So of course you're probably thinking, how am I going to remember all of these centers, which ones they are, and all that? It's a lot for sure. So that is why we're going to do a centers review down here, do some center practice, and then you're also, not today, but you're going to get a graphic organizer kind of summarizing all of the centers in one spot because they're a lot. So we've gone over every type of center. You have them in your notes. We're going to do a centers review and complete the following sentences. So I'm going to have you, what I want you to do right now is pause. Well, after I finish talking, pause the video. I want you to gather up all of your notes that I showed you at the beginning. So I'll show you what I'm talking about. I want you to look at your 5-2. You have circumcenter, incenter, these ones, right? Oops. Circumcenter, incenter, then you have centroid and orthocenter. So I want you to kind of have those out so you have a reference to all of your types of centers of triangles, and see if you can fill in these blanks. They come straight from your notes. So you do have all of this information in your notes. It would just be about going back and finding it in your notes. I want you to just try, kind of a little bit of a study tool as well. Go back and try, see if you can fill in these blanks on your own. And then I will show you the answers. It's just a review of all of the centers. And there are our answers. So you can go through and see. So the main words, so circumcenter, that's the perpendicular bisectors. Incenter, that's the angle bisectors. Centroid is the medians. Orthocenter, the altitudes. The fact about circumcenter, it's equidistant from the vertices. And then an incenter, is equidistant from the sides of the triangle.